Hey everybody, I just wanted to introduce you to the idea of atomic structure, and eventually we're going to use this information to build what we call nuclide symbols. So let's get started. Keep in mind the history of the atom and its atomic structure and what it looks like. So in the middle of an atom is this thing, which we call the nucleus. And the nucleus has in it protons and neutrons. Okay? And then all around the outside is an area or region that has electrons traveling around. Each dot doesn't represent an electron. Each dot represents kind of the electron moving all around, because the electron's kind of moving around like this. Okay, and it's going in three-dimensional space, and it'll kind of encompass this whole thing. So around the outside are electrons. Okay, let's take some time and summarize what the folks who actually researched atomic structure came up with and put that on a table. So here we have protons, neutrons, and electrons. First and foremost, I think it's important for us to kind of come up with an abbreviation that makes sense. So a proton is going to be called P, and then we're going to have a symbol for it that's a positive. You may know from previous classes that the charge on a proton is positive. We have a neutron here whose symbol is going to be an N with a 0 there, or indicating nothing. So a neutron is neutral. And then we have an electron, who I will put a blue here, and that's going to have a lowercase e with a little negative charge. That saves us from having to write out all of this information. Now, where do we find all these things? Where's the location of them? Well, the location is pretty straightforward because we just went over that. We find a proton in the nucleus. Okay? We find a neutron in the nucleus. And then we find the electron in something called the electron cloud. For a proton, eventually somebody actually found the mass of a single proton. And the mass of a single proton is going to be 1.67 times 10 to the minus 27 kilograms. So it's very, very small. Okay, I'll write up at the top here, that's 0.0000. It's that many kilograms. So it's super, 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 super tiny. It gives you a sense of how small the proton actually is. Folks also discovered the mass of a neutron, and that was determined to be 1.68 times 10 to the minus 27 kilograms. Folks then did this for an electron as well, and we ended up with 9.11 times 10 to the minus 31 kilograms. So we would add more zeros and it would be way out here. So these masses don't make a lot of sense, okay? We can't do much with them. What scientists said was, let's make what we call a relative mass, where we compare the mass of the proton and neutron and electron to each other, and that makes this much easier to understand. So what we did, or what scientists did, is say we have a mass of a proton, and we're going to set to 1, and we're going to call that 1 AMU. Okay, and then we do the same thing with a neutron. So a neutron is we're going to say they're about the same mass. So a neutron has a mass of 1 AMU. And then we say that an electron is so small that it really doesn't matter. It's about 1/2000th the size of a neutron, and so we're going to say that this is 0 AMU. So the mass of an atom has nothing to do with the number of electrons. Now for charge, this is the same sort of thing. The folks who determined the charge of an electron actually determined what we call the absolute charge, or a charge that was so very, very tiny, and it was negative 1.6 times 10 to the minus 19, and the units for that is coulombs. That's a unit of charge. Okay, and then they did further research and they determined that a proton has an equal charge but in the opposite direction. So a proton has a charge that's positive 1.6 times 10 to the minus 19 coulombs. And then a neutron was so hard to determine, it wasn't discovered until much later than the proton and the electron, because a neutron has neutral charge, so it's harder to detect. So again, just like the masses, charge doesn't really make a lot of sense to use in a kind of a day-to-day situation. So we came up with this idea of a relative charge. So the relative charge of a proton is 1 plus. The relative charge of a neutron is 0, and the relative charge of an electron is 1 minus. One last note, in chemistry, we always put the charge symbol after the number, so it's 1 plus. That way we don't get confused with the value of -1 or the mathematical term subtracting 1 or adding 1, and we know that it's a charge, so it's 1 plus or 1 minus. Okay, so we always put the charge afterwards when we're talking about relative charge. Okay, so that is the information about all the subatomic particles. Have a great day.